So this session I will talk about some problems from the course book chapter 3, and we know that the course book is Matematik Origo 4. I found a good problem actually. This is a nice problem. Of course, I wrote the English translation of that problem here, but this picture is copied and pasted from exactly the book. So this is the question, problem 8 on page 110. A bunch of graphs is given to you here. So here you see that this is the derivative. This is the graph of the derivative of function. This is the graph of the derivative of g function, and this blue curve is the function g itself. And the question is this: the function h with this rule is given. Use the graphs in the figure to determine h prime of 2 and determine p prime of 1 if p of x is defined as f of g of x squared. So in other words, this means that f of g of x to power 2. This is the definition of your p of x. And then you are supposed to use the information in the figure to be able to find the answer, the number for p prime of 1. Okay, so I will pause the video and I give you a little bit of time to think about this. So this is a nice question, I think. Okay, so any progress?
Yes.
Okay, so for example, hello, yes. What is the answer? Did you solve both parts?
The answer to the first part should be -3, and I'm finishing.
I don't know, but I can solve it. So let me at least solve the first part. So if you are not familiar with these kinds of questions, let us see. So here we want to find h prime of 2. So h prime of 2, part number 1, h prime of 2 is wanted. H of x, on the other hand, is given as a composition of two functions, f and g. So definitely this is the chain rule, yes? If I want to find the derivative of a function at a given number, the first thing that I have to do is to differentiate the function, and then at the end replace the x in the derivative with the value given, okay? But when I want to differentiate function h, it means that I want I have to use the chain rule. So the chain rule tells me that this is the derivative of f calculated at g of x, but then I need to remember to multiply by the derivative of g of x. This is what the chain rule tells me, yes? And then I know that I want to calculate h prime of 2. So what it means that go and replace x with 2 everywhere. So it becomes f prime of g of 2 multiplied by g prime of 2. Okay, and then I can use the information on the graph to answer each one of these questions. So if I want to ask what is g prime of 2, you see that this yellow line is the graph of g prime. And I want to know what is the value of the g prime at 2. So it means that this is 1, this is 2, and when I go down, I intersect with the green line here. But if I read this number is -1, -2, -3, -4. So I realize that g prime of 2 is -4. Yes? So this becomes -4 by the information given on the yellow line. But here, I have to calculate f prime of g of 2. So first of all, I need to know the value of g of 2. But the graph of g is given. The graph of g is this blue curve. And I want to know what the value of g of 2 is. So what does it mean? It means that I go 1 and 2, and then I go to the graph of the blue line, again, I will intersect exactly at the same point. So if I read this one, it is -4. So the number inside is -4 again here. There is no difference between these two values. But let me continue now. So this becomes equal to f prime. Instead of g of -2, I put -4, and then multiplied by g prime of 2, which was -4. But now I need to understand what that number is. For understanding this number, I need to refer to the derivative, to the graph of the derivative of f. But the graph of the derivative of f is this red line. And I want to know what the value is if x is -4. So this means that this is -1, -2, -3, -4. I go down to find the intersection point, but the intersection point is here, 1, 2, 3. So it's -3. So this number is -3. Okay, and then the answer becomes a -3 times -4, which is +12. So this means that the h prime of 2 is +12. I consider this a good question. It's actually testing your knowledge about graph of functions and the chain rule simultaneously. Is there any question? By the way, let me check the final answer here, if I haven't any mistakes. So this is chapter 3. I don't know where it is. So chapter 3, capital test. Yes, it is 12. That's correct. Okay, but the other one is a little bit more complicated. Is there any question so far for this simpler question?
No.
Okay. Yes? I cannot hear you. May you speak louder, please?
Can you hear me now?
Yes, yes.
What level would you consider this question?
This is A-level question. Yes.
Okay.
Yeah. Okay, so we go to the next one, number 2. We want to find p prime of 1 when you want to calculate, when the p of x is given to be this. This is more complicated because you need to be able to calculate the derivative of this function that I have a power of 2 here using the chain rule. Of course, if you remember the way that I taught you the chain rule, you will not face any problems. But in case you have forgotten, let me just do this one because there are other problems that I want to solve for you as well. So let me write it here in front of our eyes. So p of x is given to be f of g of x squared, and then we are supposed to calculate p prime at 1. Okay, so for the time being, I don't need the graph, so let me just focus on differentiating this function. So can you help me to do that? If I want to calculate the derivative of p prime, what should I write in front? Anybody?
F prime at g at x squared times, and then like brackets g of x squared, and then that's the prime.
Yes, exactly. So this is what you need to understand. Is there any questions here? So here the g of x squared is playing the role of this g of x in the formula for the chain rule. So this, you can call it in your head, you can call this one as f of capital G, but if I ask you what is capital G, you would say this is g of x squared. And then if I want to use the chain rule for this one, I usually do the same as before. So it becomes f prime of capital G of x multiplied by the derivative of g of x, the capital G of x. But the capital G of x is g of x squared. So what I have written here is exactly the chain rule. Okay, but now what should I do? I need to write it in this form. F prime of g of x squared is just, I copy and paste. But can you tell me what I can write for this one? This is
2
yes,
times of x,
2 times?
g of x.
No, not complete.
Is it 2 times g of x times g of x? Or in other words,
No.
2 times g of x squared? No, okay.
No. Why are you saying these things? I don't understand. What is u to power 2 prime?
Oh, is it
Hello?
do 2 times g of x times the g prime of x?
Yes, exactly. This is u squared. If you want to take the derivative using the chain rule, it is 2u. It's not complete. I told you, you have to multiply by the derivative of the base as well. And here, this is playing the role of u. Okay, so the answer would be times 2g of x times g prime of x. This is the correct answer. Okay, so let me write it in an organized way so that we can finally answer this question. So p prime of x, if you don't mind, let me write 2 g of x and g prime of x on the left-hand side. It doesn't matter, of course, but let me keep it in this organized way. So this is what we get for p prime of x. But now let us see what we are supposed to calculate. We are supposed to calculate p prime of 1. So this means that I have to replace x with 1. So p prime of 1 becomes equal to 2 times g of 1 times g prime of 1 times f prime of g of 1 squared. So this is p prime of 1. And then I have to calculate p prime of 1. So what should I do? I need to go and refer to the diagram. Okay, I think they are easy. If I ask you what is g of 1, probably you can immediately answer. To answer g of 1, I need to refer to the graph of g. This blue one is the graph of g. And I want to know what the value of g is at x equal to 1. So x equal to 1 is this point. I go and find the intersection point. The intersection point is minus 1. So g of 1 is minus 1. Now I want to answer what is g prime of 1. G prime of 1, it means that I need to refer to the graph of g prime. The graph of g prime is the yellow line. I want to calculate it at 1. So I go again to this 1. I go and find the intersection with the yellow line. But the yellow line is here. So if you see, this is minus 2. So this becomes minus 2. But for answering this one, I need to write g of 1 to power 2. But I just calculated g of 1 here. You see, g of 1 is minus 1. So this one here, this one becomes minus 1 to power 2, which is, of course, 1. So let me write this now a little bit simpler. So here, 2 times minus 1 times minus 2 is positive 4. And then I have f prime of 1. But again, to answer the last part, I need to refer to the information, I need to refer to the graph of the f prime function, which is this red line, and I have to calculate f prime at 1. So this is 1. If I go and find the intersection is 2. So f prime of 4 is 2. And the answer becomes 4 times 2, which is 8. And the final answer to this problem is p prime of 1 is 8. Okay. Any questions? So I consider this a nice problem. I think I haven't talked about these kind of problems when I was teaching, so I was thinking that it is a good idea to discuss about this here. Any questions? Is that understandable? Okay. Let me now go to the next problem. It's not hard, but I want to give you a little bit of time first yourself to solve this problem. Okay. Problem 3249, page 97. So let me read the question. The tangent to this curve, y equals to the x to the 3 times e to power minus x at the point where x is equal to 4, together with positive coordinate axes, with positive parts of the coordinate axis, make a triangle. Determine the area of the triangle. Okay. So I want to pause the video and give you a little bit of time so that you can think about the problem yourself first. So let me pause the video here. May you please refer to the video because I see there are some misprints here. I want to fix them. Okay, I would appreciate if you look at the book. Problem 3249, page 97, okay? Okay, any progress? Nothing?
I calculated tangent line, I guess, but that's it. And I don't mean the slope, I mean the actual tangent line.
Okay, so okay, if that's the case, then probably what is left is just minor things. Okay, I don't know, do you want more time?
I think it would be the best
Because
for
there are more problems. I want to finalize all of them, so I will give you a little bit more time now. Okay, now hopefully you were able to solve this problem. This problem, I don't consider it hard, even though it is a level 3 problem. Yeah. So first of all, you shouldn't bother yourself for drawing the graph of this function. Okay, so you need to put the responsibility of the question for the person who actually designed the question. So if I want to solve this problem, I don't spend time on drawing this graph carefully. Okay, but what I need to understand is that, okay, so I will just sketch something for myself here to understand the problem. Of course, it is clear that if I put 0 here, the function becomes 0, so that is definitely a point. But how this function acts, I don't care. But of course, this is clear that if this function is going to be in this form, then the tangent line will not make a triangle with positive x and y coordinate axes. Yes, so it means that somewhere in this graph we need to have something like this, for example, and then the tangent line then makes a triangle with the positive x-axis. Yes, so something like this. That is enough to know. So this is why I don't bother myself that much to draw the graph. I would say that this is 1, 2, 3, 4. So this is 4. So around that point, probably the curve would be something like this. And let me make it a little bit lower so that I can fit anything. I don't care about the real value and the real form of the graph at all. Okay, so something like this is enough. And then when I draw the tangent line here, this tangent line will make a triangle with positive and with positive. Let me make it better. With positive x-axis. Yes. So this is the x-axis. and this is the y-axis, and this, let me call it the O, and let me call this point A, and this point B. This is what you need to sketch. You really don't need to bother yourself to make everything very precise. This is what you need to understand. Is there any questions so far?
No.
Okay. Now I want to find the area of this triangle. I know that this triangle is a right angle triangle. So to be able to answer the area, I need to know this length, and I need to know this length. And then for finding the area of this right angle triangle, I multiply these two lengths and then divide it by 2. And to understand what are these lengths, I need to know the equation of this line. And then the y-intercept is this number, and the x-intercept is this number, as simple as that. Okay? So the first thing that I understand by this analysis is that I need to know the equation of my tangent line, and this is a very typical example. To know that, I need to start with my function y equals to x to the 3 times e to power minus x. I need to calculate the derivative because I want to find the slope. Yes, so if I calculate the derivative, this is something that we learned as the product rule, because that's the derivative. That is a function which is the product of two other functions. So I have to use the product rule. The product rule, if you remember, is this. If I have the product of two functions I want to differentiate, it becomes the derivative of the first one multiplied by the second one, plus the first one multiplied by the derivative of the second. So then let me write it in detail. So this becomes the derivative of the first one multiplied by the second one, plus the first one multiplied by the derivative of the second. The derivative of x to the 3 is 3x squared, e to the power of minus x. And then if you remember, the derivative of e to power minus x is minus e to power minus x. So I put this minus sign here. This becomes minus x to the 3 e to power minus x. Of course, here I can simplify it, even though simplification is not necessary. So I can factor x squared e to power minus x out. So then it becomes 3 minus x squared e to power minus x. To check that I have done correctly, I can multiply this back here. This gives me this. And if I multiply this back here, this will give me this. So that is the derivative of the function that I just found here, yes? But I want to find the slope. So the slope is the derivative calculated at the x coordinate of the point of tangency. So if this is the point of tangency, the x coordinate is definitely 4. So I need to calculate the k value using this. So the k value of the tangent line is y prime calculated at 4. So it means that I go to the derivative and replace x everywhere with 4. So this becomes 3 minus 4 times 4 to the 2 times e to power minus 4. And if I calculate this, it becomes minus 16 e to power minus 4. And you have to work with the exact values, okay? So that is the k value that we have. Minus 16 e to power minus 4. So let me write it here. So this is my k value. But now you know that the equation of any tangent line, because that's a straight line, follows this form: k value times x plus the y-intercept, which is m. Of course, now if I ask you what are the coordinates of the point of tangency, it is easy to answer. X coordinate is directly given in the problem to be 4, but because this point lies on the graph, it means that if I want to find the y coordinate, I need to put 4 here. When I put 4 here, it becomes 4 to power 3, 64, e to power minus 4. So this is the y coordinate of the point of tangency. So let me write it here, 64, e to power minus 4. On the other hand, I know that this point of tangency is also on the tangent line. So it means that its coordinate should satisfy the equation of the tangent line. But I already know the k value. So y is equal to minus 16 e to power minus 4. This is my k value I put instead of k. After that, I will have x, and after that, I will have my m. Okay, but now I want to find m. Okay, this means that I need to put the coordinates of the point of tangency in the equation of the tangent line. So instead of y value, I put 64 e to power minus 4, and instead of x value, I put 4. So if I put 4 here, this 4 will be multiplied by minus 16, it becomes minus 64 plus m. And then immediately, if I move this to the right, it becomes 64 e to power minus 4 plus 64 e to power minus 4 is equal to m. So this means that m is equal 128 e to power minus 4. This is my m value. And by the way, m value is the y-intercept. So if I ask you what is the height here, you can immediately now answer, because this height is actually the y-intercept. So now we realize that this is 128 e to power minus 4. But let me now plug it back into the equation. So I will take it and put it here to finalize my equation of the tangent line. So y becomes equal to minus 16 e to power minus 4 x plus 128 e to power minus 4. This is the equation of the tangent line, yes? D is not the correct word, an equation for the tangent line. Okay, but now I want to find the x-intercept. I want to find this length. So in order to find the x-intercept, this point lies on the x-axis. It means that the y-coordinate of point A is 0. So if I plug y equal to 0, then I will get minus 16 e to power minus 4x plus 128 e to power minus 4 is equal to 0. Now I want to find x, so it becomes minus 16 e to power minus 4x is equal to minus 128 e to power minus 4. And now I divide both sides by e to power minus 4, it is cancelled. And then x is equal to minus 128 divided by minus 16. And this becomes 8, yes? So x becomes 8. So this means that the x-intercept is 8. So if I go back here, this length from here to here is 8 units. And then, of course, if I want to find the area, so let me write the area. So therefore, the area is equal to 128 e to power minus 4 minus times 8 divided by 2. So which is equal to, this is 2 to power, so it is 512 e to power minus 4 area units. So the area is actually 5. This is the exact value of the area. Okay, any questions? Is that understandable? So I don't know if this, of course, this is a level 3 problem, but I don't think it is hard. It's completely algorithmic. You can just follow what you need. So the only thing is that don't waste your time to draw a very precise picture. You don't need that. Okay. By the way, let me check this one. This problem is 3249. I want to make sure 3249. Yes, the answer is correct. Okay, now we go to the next problem. Again, I want to wait a little bit for you and then solve the problem. This is problem 3227 on page 93 of this Origo 4 book. Okay, so I will give you a little bit of time to think about it. After that, I will have only one problem left, and then we finalize this session. Okay, any progress? I saw that one of you answered that is correct. Is the question clear? I was trying
Yes.
to actually do some animation with this GeoGebra. I see also another answer probably. Yes, so the answer is e to power minus 3. Yes, that's correct. So let us see how we can solve the problem. So let me first solve the problem, and then if I can show it to you what the meaning of this question is. So again, you need to have a sketch on the graph. So if you want to understand the problem better, you can sketch a graph for yourself. So here, this would be, so let me make it this part a little bit bigger. So the graph of ln of x, of course, this is why I'm telling you, you really don't need to know exactly these things. So the ln of x actually passes through 1, and this is something like that. And then you have f. This line has the y-intercept equal to 2. So this is your y. And then, of course, k value is not clear. So it means that this definitely is a line that passes through this, but k value is not clear. So by changing k, what happens? You start rotating this line in either direction. And then we want to fine-tune it in a way that this becomes tangent to this line. Yes? So this is clear that if I start changing the value of k, I will actually consider all these lines that have the y-intercept equal to 2, but I will start rotating them around. None of them are tangent to this blue curve except one of them. So you see, one of them is tangent here, and then I want to fine-tune the k value in such a way that that particular line becomes tangent to the graph of the ln of x. Okay? So this is the idea. So how should I solve that problem? So let me, for example, choose one of them. Assume that this is your tangent line. Okay. Assume that this is your tangent line and it is tangent to the graph here. And let us call it the point of tangency. The hard part of this problem is that you usually have the coordinates of the point of tangency, but here you don't have the coordinates of the point of tangency. But you can pretend to have it. What do I mean by pretend to have it? This is a good technique to remember. So I don't know the point of tangency. Let us pretend that the x-coordinate of the point of tangency is some number called a. Of course, a is not known yet. But then this x-coordinate would be a, but can you tell me what would be the y-coordinate now? What is the good point? Of course, for the y-coordinate, I can choose another letter, but then I will face two variables. What?
The ln of a.
Yeah, that is a better one because it is better to bring in as few as possible. The number of variables should be not that much. So if I choose a for the x-coordinate, it is better to stick with it as much as possible. So the y-coordinate would be ln of a. If you tell me that do you know these coordinates, I would say no, but at least I see the relation between the x and y coordinates here. For the time being, let us pretend that a is a given value. Okay, if I ask you what is the k value here, you just point this number. This is my k value of the tangent line. And you already know how to find the k value of the tangent line. What we need to do is to differentiate the given function. So when I differentiate it, this is a famous function. You know the derivative is very simple. It's 1 over x. And if I ask you find the k value, what is the k value? The k value is 1 over a. Do you agree? Because the x-coordinate of the point of tangency I am pretending is a, I determined the derivative. Now I want to find the k value. The k value means I need to replace x with the x coordinate of the point of tangency. When I do this, the right hand side becomes 1 over a, the left hand side becomes the k value, and you see that this is also the k value. So this is a combination. This is what I get by understanding it in this way. Okay, so what's happening now? I know another time, and I also know what? I also know that this point of tangency is also on the tangent line. So it means that its coordinates should satisfy this equation. So it means that instead of y, I put ln of a. Instead of k, I put 1 over a. I just got it. Instead of x, I put a again. So you see the x coordinate is a. I put x coordinate here. And instead of k, I put k here. And instead of this y, I put this one. I'm just writing that. So this becomes times a plus 2. Yes. So this means that ln of a is equal to, if I simplify this a with that a, it becomes 1 plus 2, it becomes 3. And then you hopefully know that a is e to power 3. So what I was looking for a, I found it. But now I want to find k value, yes, because the question asks you about the k value. Of course, when I know a, I put it here, and then you get the correct answer as you mentioned here, yes? So e to power 3, which is e to power minus 3. So the k value is e to power minus 3. Yes? So, yeah, is that clear?
Yes.
Okay, so because if I stop sharing here now, so let me see if it works. Of course, this is not a very effective one, but you see here, this is my line. So if I start changing the k value, you see the line starts rotating about that O as we predicted, okay? And then this curve that you see is the graph of the ln function. And then of course, it means it is clear that if I start rotating this at some point, of course, it is hard to detect it with eye, but at some point, this black line touches the curve, yeah? So at some point, yeah, so that was the point. We were able to fine tune, I don't know if that's the correct value or not. Of course, this is an approximate value. What we get by calculation is the exact value. So that's the idea. We are fine-tuning this k in a way that when this line rotates about the point 2 on the x-axis, it will exactly become tangent to the graph of this function. Okay. Okay, so this problem is probably the hardest one. It is problem 3130 on page 80. So let me read it for you. A straight line that passes through the origin intersects this curve 1 minus 0.25 times x squared at 2 points. Show that the tangents at intersection points are perpendicular. Okay, I want you to read the problem and think a little bit about that. Of course, because this problem is lengthy, I cannot give you very much time. So 4 or 5 minutes at least to digest the problem. I want to solve the problem, okay? Okay, any progress?
I thought I had done some progress, but then I
okay, so
reached a
let me see. This problem is a little bit tricky. So well, let me explain it because we don't have that much time. I don't know. Just wait a moment. If I can just show it on GeoGebra to you. So. So hopefully you can see the GeoGebra screen. So this parabola, of course, is the graph of that function that you have. Yes, this is y minus 0.25. This is, of course, the parabola. I have chosen one of the lines that passes through the origin, of course. I have chosen a particular function, y equals to x, that is this red line which passes through the origin. Of course, this problem is more general than that. It tells you that if you choose any line passing through the origin, it doesn't matter. This is always true. But at least I want to try to show that this is working here. So this is my parabola, this black one. This red line is one of the lines that passes through the origin. And if I find the intersection point of the red line with this parabola, you see that I get two black points here. This tells you that if I draw the tangent line to the parabola at these two black dots, the lines will be perpendicular. And it doesn't matter if this is this red line or I change the red line to another line that passes through the origin. If I do that, I will get the same scenario. So let me see if I can show this to you. Let me see. There should be some way that we can draw tangents if it works here, of course. Let me see. So I will choose this parabola and this line. Yes. So you see this new line is the tangent line to the parabola at this point. I will do the same thing with this point. And then this is these two. And then you see that hopefully this is very clear that this angle, if I can show this angle, so I need first to find the intersection point between these two lines. When I found that intersection, I go and use this. Oops, the other way around. So sorry. Here, from here to here to here. And that's exactly 90 degrees. So that is the content of this problem. It tells you that if you choose any red line, not just only this y equal to x, y equals to any kx, and then when you find the intersection points and then draw the tangent line to the parabola at these two intersection points, they will be perpendicular. Okay? And it doesn't matter which line you choose as your line passing through the origin. Okay, so that is a good picture. You can see it. Okay, so let me go back to the solution. Okay, now we want to solve that problem. Okay, so what I want to do it quickly, but if it goes beyond the time you can leave, I will publish the video. You can see the solution later. Okay, but we have 10 minutes, around 10 minutes. So here, let me just sketch what I drew there for you. So here, I don't want to be very precise, and this is really what you need to do in the exam, okay? So you really don't need to be worried about the exact drawing. So this is why I'm a little bit careless to show that this doesn't make any difference. And then I know that a line that passes through the origin is this one. What is important for you to know? What is the general form of the equation of the lines that passes through the origin? So the y-intercept is 0, but the k value we don't know. The k value we don't know, so this becomes equal to y equals to kx. So this is the general form of all possible lines that pass through origin. And then I will get two intersection points here and here. Let me call one of them A, let me call the other one B. Okay? And now I want to find I want to have the tangent line. So one tangent line is here, and the other tangent line here is, of course, in my picture, this is very, very poor. It should be 90 degrees. It is not here, but you have the good picture there. So you have it in your mind. But how should I prove this? I want to show that these two lines are perpendicular. So it means that I need to find the k value for this one. I need to find the k value for this one and multiply the k values together. If the answer becomes -1, then I have shown that these are perpendicular. Yes? So my point is to find the k value of each one of these green lines. Okay? But how should I find the k value of these green lines? I have to differentiate my function and put the x coordinates of the point of tangency there. But the problem is that I don't have the point of tangencies here. The only information that I have, these are the points of intersection between this red line and the blue curve. So if I want to find that, I need to make a system of equations. Y is equal to kx, and the other one is y equal to 1 minus 0.25 x squared. If I equate the y values, then it becomes kx is equal to 1 minus 0.25 x squared. I move everything to the right-hand side because my goal is to find x. I am pretending that I know k value. Okay? So I move everything to the right-hand side, then to the left-hand side, it becomes 0.5 x squared, and then I have plus kx, and then I have minus 1 equals to 0. And if you don't mind, let me multiply everything by 4 to get rid of this decimal point number. So if I multiply everything by 4, it becomes x squared plus 4kx minus 4 equals to 0. Now tell me, if I solve this quadratic equation, in general, I will get two answers, x1 and x2. Can you tell me what are these x1s and x2? If I solve this problem until the end, it's a quadratic equation. I use ABC or PQ formula to find x1 and x2. What is the geometric interpretation of x1 and x2? Hello?
If we multiply.
I guess you take the derivative of y and then put.
No. I don't want to ask. I'm not asking the. Please listen to my question. What is the meaning of these numbers?
It's bx and ax.
Yes, the other way around. These are the x of a and x of b. Yes, because you see, this one is this line, and this one is this parabola. When I put them in a system and solve them, it means that I want to find the intersection points. I eliminate y from both of them, then I will get an equation for x. It gives me two values in general, x1 and x2. I'm asking you, what are these numbers if I found them? You will say that one of them is the x coordinate of one of the intersection points, and the other one is the x coordinate of the other intersection point. Is that clear? Okay? Yes? So assume that, is that clear or not?
Yes.
Yeah, okay. So this, in general, it will give me two solutions. Of course, the solutions are complicated. And when I see the solution in the book, it has given you a lot of square roots and things like that. Let me pretend that these numbers are x1 and x2. Okay, it gives you two roots. So in principle, for example, the A has x1, and I don't know with this, what is this one? If I want to, I can find it, but I don't care for the time being. Let me assume that B has x2 and this. Okay, x1 and x2, if I want, I can calculate them in terms of k, of course, using the ABC formula. But I don't want to mess it up. Let me just pretend that we have already calculated them. But I want you to understand what's going on. And now, if I ask you, what is the k value of this line? What is the k value of this line? Let me call this one k1, the k value of this, and the k value of this k2. Can you tell me how should I calculate k1? Now I think, Khulud, you wanted to answer this one. How should I calculate k1?
You take the derivative of y and put x1.
So let me just do it step by step with you. So I take the derivative of my y. So the derivative of y is very simple. The derivative of 1 is 0, 2 goes down, multiplied by that, it becomes minus 0.5x. So it becomes x divided by 2 negative, yes? And then what is k1? Can you tell me what is k1?
It's minus x1 divided by 2.
Very good, thank you. This is x1 divided by 2, yes? And now, what is k2? I hope that everyone knows that this is also the same. Agree with me? Yes? But what was my goal? My goal is to show that these two lines are perpendicular. So this means that I need to show that k1 multiplied by k2 is equal to -1. This is my question mark. If I can show the product of these two numbers is equal to -1, then I am done. So let me multiply them then. So K1 multiplied by K2 becomes minus X1 divided by 2 multiplied by minus X2 divided by 2. Then it becomes 1 over 4 X1 X2. Okay. Let me just write you one simple idea. I don't know if you know about this. This is very good to know. The book has proved this in the solution, because when you see the solution in the book, it was complicated because it is not relying on this, that you know about this. If you have a quadratic equation with two roots x1 and x2, if you want to find the sum of these two roots, of course, you can first find the roots and add them. But there is a shortcut. You can just write minus b over a. And if I ask you what is x1 times x2, again, you can find each one of the roots and then multiply them. But then it becomes, if you don't want to do that, there is also a very nice formula for that. It is c over a, okay? In the solution in the book, this part is also being proven. This is why the solution is long, is long. But assume that for the time being, you know about this. If I ask you now, what is x1 times x2, you would say that x1 and x2 are the solutions of this equation. And if we take this for granted that the product is c over a, then I immediately realize that from here, if I ask you what is x1 and x2, you would say that this is c divided by a. But in this problem, c is -4, a is 1. So this becomes -4 divided by 1, which is -4. And then if I plug it back here, then it becomes 1 over 4 times -4, which is -1. So if you use this in the exam, of course, this is not in the formula sheet. I will accept it from you because this is a very famous one. And then, of course, now you can leave the exam, the session, but I want to show that this is indeed the case. So you don't miss anything. I will upload the video later. Okay, so why these two formulas are correct? Because here I know that x1 is minus b plus square root of b squared minus 4ac divided by 2a, and then x2 is minus b minus a square root of b squared minus 4ac divided by 2a. It is completely clear if I add these two, because these two have the same denominators, I will write the same denominator, and then I will add the numerator here to the numerator there. But these two negative and positive will be canceled. I will get minus b and minus b, which is -2b. So x1 plus x2 is -2b divided by 2a, which is b over minus b over a, and that is exactly what I have shown here. But that is an extremely important formula which is missing from the Swedish system. I don't know. So you need to know that if you have a quadratic equation, the sum of the roots is minus b over a, and the product of the roots is c over a. But the product is more interesting. So let me also show that one, and then that's the end of the lesson. So if I want to multiply x1 by x2, it becomes minus b plus square root of b squared minus 4ac divided by 2a multiplied by the other root, which is minus b minus square root of b squared 4ac divided by 2a. But if I want to multiply these two fractions, the denominator is simply 4a squared. But these two make a conjugate pattern. So this becomes the first one to the power of 2 minus the second one to the power of 2. But the second one to the power of 2, I will get rid of that square root sign. And if I simplify this, it becomes positive b squared, negative b squared plus 4ac divided by 4a squared. And then these two are canceled, so I am left with 4ac divided by 4a squared. And then everything is simplified. I am left with c over a. If you go and see the solution in the book, the reason that solution is a little bit long, because it is proving this part in that problem. You can do the same thing, but you can have it in your memory to use it when it is necessary, because this is a very well-known fact about quadratic equations. Okay, I hope that this video was useful actually. So you see that there are some hard questions in the book. This is not the case that always my questions are hard. Some of them, these questions are actually considered hard questions. Okay, so I will stop this video now.